Welcome to this video. My name is Steven, third year student of Civil Engineering, Makerere University. This is Group 1 of Construction Technology course unit. With me, I have my colleague,
Mr. Makerere, also Civil Engineering student at Makerere University.
Yeah, so Tumsime Kasanga.
Yes, please.
Can you briefly give us the content of the video? What are you going to present tonight?
Okay, thank you, Mr. Steven, for this. My main purpose today is going to be introducing the main purpose of this video and as well the summary of the project initiation stage in the project management cycle. Typically, the project goes through 5 stages, which includes the initiation stage, whereby in the initiation stage we usually do the project charter, we do the feasibility study, and also at times identify the stakeholders to be included in the project. And secondly, we have the planning stage. In the planning stage, we usually come up with the objectives and goals to be achieved within the project. And the key activities involved in this stage is organizing the resources, doing the fundings, and all other activities. Then thirdly, we usually have the execution stage. Okay, from the execution stage, we ensure that the project is completed in its estimated period of time and ensure that all the deliverables shown all earlier stated in the project planning are achieved in its estimated period of time. The fourth stage is the monitoring and controlling, and we track, review the performance and progress of the project. At this stage, the key activities mostly followed ensuring that the earlier on estimated deliverables are achieved, and those that are underachieved are again monitored and then worked upon as supposed to be. Then lastly, we usually have the closure stage, whereby we do the handing over if at all the project is well done. Then now, my main focus today was the initiation stage. In the initiation stage, usually the first stage of construction project, and is crucial for setting the foundation of the entire project. In this stage, we also have several activities that we are supposed to be following in their order. To begin with is the defining the goals and the scope of the project. This is where we establish the project's objectives and what it aims to achieve. Secondly, we usually have the feasibility study in the second stage of the initiation. And here, we do conduct a feasibility study to assess the project's viability, evaluate factors such as cost, time, resources, and potential risks. Then in the third stage under initiation, we usually have the project charter. In the project charter, we usually create a project charter that outlines the project's purpose, objectives, and stakeholders, plus the key milestones that we are to achieve in the project. Then in the fourth stage under initiation still, we usually have stakeholder identification. And in this, we identify stakeholders, of course, involved in the project, including clients, contractors, engineers, and the regulatory bodies. Then in the fifth, we usually have assembling the project team, those responsible for doing their activities, qualification, procurement, construction analysis according to their roles, and lastly, initiating of the project, usually called the initial planning. We develop an initial project plan that includes timelines, budget statements, and then resource collection. Okay, to invite is my next colleague, Mr. Makerere.
My name is Gift Raymond Aineviona from Group 1. I'm here to talk about site reconnaissance. Site reconnaissance refers to gathering of specific data to inform the design, construction, and maintenance of the engineering project. Key activities that are done in site reconnaissance include visual inspection, topographic surveys, geotechnical investigation, and environmental assessment. And among the tools used in site reconnaissance, we have normal cameras. Normal cameras are manually and automatically operated, and they help us to capture visual images and videos. And their scope of operation is visual inspection. We have drone cameras. Drone cameras help us to get aerial maps and images. They are automatically operated, and their scope of operation is aerial survey. We have ground penetrating radars. They help us in subsurface imaging. They are manually and automatically operated. They help us in subsurface investigation. We also have GPS. GPS helps us to get location and elevation data. It is automatically operated, and their scope of operation is geolocation survey. We also have soil sampling equipment. Soil sampling equipment helps us collect soil samples, and it is manually operated, and their scope of operation is geotechnical investigation. Thank you.
My name is Buregyeya. I'll be taking you through the survey processes. Boundary surveys, these are processes carried out to determine property lines and find true property corners of pieces of land. The accurate identification and marking of these property boundaries is based upon a foundational field survey that involves physical measurement and assessment. We are going to get into the tools and equipment used by surveyors in these processes. First, we shall look at the total station, field lights, survey roads and levels, the GPS and DNS receivers, have automatic and digital levels. First of all, I'll give more detailed explanation about the mode of operation, the cost, the scope, and range plus the scope of work. Total stations, basically, these are a combination of electronic field lights and electronic distance measurement devices. They measure distances and angles, basically from a specific point to various targets, typically which are prisms and reflectors. The cost range depends on the specifications and regulations, which is basically between 10,000 to 40,000 US dollars. The range and capacity, they normally operate within a distance of 5 to 6 kilometers within a 5mm level of accuracy. The scope of operation, we look at them as used when measuring distances, angles in boundary surveys, look at road constructions and road alignment, also look at topographic surveys. Drones capture living imagery and LiDAR data relate to 3D models and topographic maps. LiDAR data, which is light detection and ranging data, is collected by mounting sensors on the aircraft which detect reflected pulse laser beams. The cost of drones ranges between 15,000 US dollars to about 35, depending on the specifications and purpose. The capacity and range depends on the battery life, which covers up several square kilometers. The scope of operation, look at most especially drones are used in mapping large areas and those that are actually inaccessible. So we get into another equipment used in boundary surveys, which are RTKs or GNSS and GPS receivers. The mode of operation of an RTK, you set up a base station over known or unknown points. This continuously receives all the visible GNSS signals from all the available satellites and sends the base code coordinates and the pseudo range data to the rover via a wireless network or link. During operation, the rover can be moved from the base station since it is static within a range of 10 kilometers. The RTK basically captures data within a range of 10 to 20 kilometers. The cost varies depending on the specifications and the use and the purpose. So basically, we look at RTKs ranging between 12,000 US dollars to about 48,000 US dollars. The scope of operation, RTKs are basically used in determining reference points for specific ground markers. Let me invite my colleague, Mr. Gapeto Barnabas, to continue with more other equipment used in boundary surveys.
The equipment of surveying, we have EDM, electronic distance measurement. That one uses light or radio waves to measure the distance between 2 points at rate. The cost is between 1,000 to 15,000 US dollars, depending on the features. And the capacity is up to 10 kilometers with some millimeter precision in some models. The scope of operation commonly used for measuring long distance in open areas and often integrated into total stations. We also have the theodolite. The theodolite measures vertical and horizontal angles. It is manually operated by the surveyor, and the cost is between 15,000 US dollars to 10,000 US dollars. And the capacity, depending on the visibility, the theodolite can measure angles over long distances. The scope of operation is to measure angles between points in boundary surveying, providing the foundation for calculating distances and establishing precise boundaries. And the third one, we have surveying roads and levels. Surveying roads are used with levels and total stations to mark specific points on the ground. Well levels are used to measure height differences. The cost is between 100 to 500 US dollars, and its capacity is up to several hundred meters depending on visibility. The scope of operation used for establishing benchmarks, measuring elevations and marking points on the ground for boundary identification. And the fourth one, we have auto level or digital level. Auto levels are optical instruments that help measure differences in elevation by establishing horizontal line of sight. The cost is between 4,000 to 6,000 US dollars. The capacity and length is up to 500 meters with millimeter accuracy for elevation measurements. And the scope of operation is used to determine elevation changes in boundary surveying, especially when mapping and event terrain. Thank you for listening. Let me introduce my colleague, proceed with the next equipment.
Hello everyone, my name is Emmanuel Chemos, a student of Makerere University, Civil 3. I'll be discussing about geotechnical engineering equipments used in design and planning of a project. First of all, geotechnical investigations are essential for informing the planning and design of the construction project. They involve assessing the rock and soil properties to ensure the stability and safety of the structure. These equipments are subdivided into 3 forms. We have the laboratory equipment, the field testing equipment, monitoring equipment, and the geotechnical equipment softwares. Some of the laboratory equipments, we have the triaxial cell, designed to evaluate the shear strength and stress-strain behavior of the soil specimens. The average cost is around 1,500 US dollars to 24,000 US dollars. Next is the direct shear machine, designed to measure the shear strength of the soil samples. The test machines can be automated or manually operated. The cost is around 10,000 to 11,500 dollars. Then we have the consolidation test. The consolidation test measures the rate and magnitude of the soil consolidation and axial loading, primarily for saturated cohesive soils, also known as the standard odometer test. It assesses how soil volume decreases with subjected stresses, allowing engineers to estimate settlement for construction projects. The compaction test apparatus, this one assesses the density and stability of the soil, particularly in construction. It measures the relationship between moisture content and dry density under specified compaction energy. Then we have the field testing equipment. We have the blade load
test equipment, also known as the plate bearing apparatus, is essential for assessing the soil bearing capacity and settlement behavior in construction. We have the CBR test equipment, California bearing test, measures the strength of the subgrade soil for road construction. It comprises the load to penetrate the soil sample that needed for the standard crushed stone to specified depth. We have the DCP, dynamic cone penetration testing, for assessing soil properties, particularly its strength and bearing capacity. It is favored for its real-time data collection and minimal disturbance to the soil. Then, on the monitoring equipment, we have the inclometer, which measures the tilt, slope, elevation, and depression of an object concerning the gravity. Inclometers can be digital or mechanical. They cost around $13 to $206. Then we have the tiltometer, which is designed to measure the small changes from vertical level, either on ground or on structures. It's commonly used in various applications, including geotechnical investigation. Its cost is $13 to $500. Then we have the extensometer, which measures the elongation and deformation of materials under stress. Settlement gauges monitor the ground displacement and settlement in various structures such as impoundments and tunnels. Their cost is around $1,000 to $10,000. Then we have the geotechnical software equipments. One is the Plaxis, which is the leading software suite designed for geotechnical engineering applications. Then also we have the GeoStudio, integrated geotechnical analysis software suite designed for analyzing various geotechnical problems. Thank you so much. Let me invite my colleague John Paul to take us in the following part.
Hello everyone, I'm John Paul, a member of Group 1, continuing from where my colleague stopped on the tools and equipment used in geotech investigation. One of those tools that are used in geotech investigation include the agar drill. This agar drill is widely used in different fields, including environmental engineering, geotechnical engineering, and some other construction projects. For it, it is an automatic. It is an automatic and manual. It is handheld and also one that uses machine. Its cost is ranges from $200 to $30,000. The next one is the percussion drilling rig. This is a technique which is primarily used for drilling through hard rock and compacted soil. This method utilizes percussive action to break material, the soil material. For it, it is an automatic machine that uses the modern techniques for extracting material from the soil. Its price ranges from $50,000 to $100,000. The next tool is the shell bite tube. Shell bite tube is a cylindrical tube. A cylindrical tube that is thin wall, which is used manually actually for picking soil samples from the required site. For it, it is mainly used on consolidation test. Its price is just $11. The next one is the split spoon sampler. The split spoon sampler is a cylindrical tube that is split into two. For it, it is a manual. Before you use, you first join them together and then it is pushed to the required depth where the samples are supposed to be picked, and then it is pulled out, which is then unpacked to get the soil sample. Then its cost is ranging from $50 to $52. The next one is the cone penetration test. This is one of those tools that is also used in geotech investigation. It is both manual and automatic depending on the person who is using. Its cost ranges from $2,500 to $2,950. The next one is the van shear testing equipment. It is inserted. It is inserted into the soil, and then it is rotated for us to get. After rotating, the value, the strength, the shear strength of the soil is then read off from the machine. Its cost is ranges from $1,200 to $1,500. Finally, we have the ground penetrating radar. The ground penetrating radar is a geophysical method that utilizes electromagnetic waves to image the surfaces of the soil. This one is an electric device. Its price ranges from $11,000 to $17,000. Thank you.
Moving on to environmental surveys, in which the symbiotic relationship between the environment and civil structures is studied. Most environmental survey operations are conducted by picking samples from proposed site areas and running them through various specialized laboratory tests. Otherwise, in modern times, there is a large assortment of specialized tech and software to conduct environmental surveys. Main areas of operation in environmental surveys include first, flood risk assessment, where an assessment of how likely it is that a proposed structure will flood is conducted using modern tech tools like the closest NOAA tide gauge, a coastal flood threshold, tolerable number of days of high tide flooding, or a set of sea level rise predictions and flood insurance rate maps, among others. Second, contaminated land assessment, where we assess and do due diligence of the level of threat posed to an existing or proposed structure. It is near a site that is currently or has been in the past used for industrial waste disposal purposes. Third is environmental screening for underlying conditions like ground gas or any due errors due to closeness to waste disposal systems. Fourth, the risk assessment of fire. This assessment is designed to set what could start a fire, how the fire could be dealt with, and ensuring that the occupants will be sufficiently warned of the fire, have exits from the building, and a safe place to congregate afterwards. The tools for this survey can be as simple as a well-detailed checklist for the mentioned areas of concern. Other surveys within environmental surveys include baseline surveys, asbestos surveys, and life cycle assessment. In modern tech tools used in environmental surveys, as mentioned above, can include S3 ArcGIS Pro, which is suitable for scientists and planners alike. Its pricing varies by licensing type, with key features like distance analysis, basic proximity analysis, and feature comparison analysis. 2 could be the FEAT 2.0, which is suitable for humanitarian and emergency response, with a pricing that varies by license type. 3, OpenLCA, which is free and with paid support as well as open source, and allows data integration and conduction of environmental surveys. Lastly, the GAP-LCA, which is suitable for environmental teams and product managers on subscription basis, which can have features like scenario analysis and data quality management. All these tools are important in assessing the impact of the environment on a project and vice versa. Thank you.
Thank you. My name is Kasigas William. I'm presenting utility survey tools and equipment. To begin with, identifying survey utilities is crucial for safe construction. Let's explore the survey tools and equipment. 1, we have the ground penetrating radar. This uses radar pulses to detect underground utilities. 2, we have the electromagnetic inductive device. This uses electromagnetic fields to locate underground utilities. Then 3, we have the GPS and GIS maps. GPS and GIS maps accurately map utility locations for future reference. 4, we have virtual excavation trucks. This is a non-destructive method for exposing underground utilities. Other tools include the augers, drill rigs, and among others. In conclusion, utility surveys help us to efficiently and safely work on a construction site. These equipments help us to accurately map and identify utility equipment. Thank you.
Hello, my name is Makerere, and I'm taking us through the design tools that we use during the construction project. Many tools are involved during the designing process, and these tools help in facilitating planning, visualization, and execution. One of the tools that we use during this stage is the CAD tools. That stands for computer-aided programs or designs or softwares. These tools or programs are used in designing detailed 2D or 3D designs, and they are mainly used by architects and engineers to visualize structures and layouts. Their subscription fee starts from $100 depending on the number of seats. Another tool or other tools that we use are the building information modeling tools. For example, Autodesk Revit and ArchiCAD. These BIM tools, for example, Autodesk Revit, ArchiCAD, allow for creation of detailed 3D models that include data about materials, costs, and timelines. These tools help in improving collaboration among stakeholders, and their subscription fees start from $12 per month. Other tools that we use are the project management software tools. For example, Microsoft Project. These tools are used mainly in planning, scheduling, and managing resources throughout the project lifecycle. Their subscription fee starts from $12 per month. Other tools that we use are the virtual reality and the augmented reality. This is the same category, and they're used for immersive visualization of projects, allowing stakeholders to experience design in a more interactive way. Their subscription fee starts from $29.99 per month. Other tools that we use are the cost estimation softwares. For example, SAG estimating. These tools are used to provide accurate cost estimation based on labor, materials, and other factors. And let me call upon the next colleague. Thank you for listening.
Very much. This has been group 1, and these were the people who presented. We had Buregyeya Gift Raymond, we had Buregyeya Hilary, we had Kemos, Emma, Kamochi, we had John Paul, we had Nabanja Alu, we had Musime Stephen, we had Musime Kasangaki, and Buregyeya Ignatius as part of the group. We had Asigazi William, and we had me myself, Principal Robert. This has been group 1. We are thanking our lovely lecturer, Engineer Dr. Buregyeya, for the assignment. Please like and subscribe to the channel. Thank you very much. See you.